Hello friends, I welcome you in lecture number 7 on Laplace transform. In this lecture we will discuss one more question on finding the Laplace transform of given functions. So first we consider this function sine 2t times cos 2t, and we are asked to find out Laplace transform of this function. And we have seen linearity property for Laplace transform, but we have no property like this. Here in this number 1 you can see we have this type of Laplace transform of product of two functions. So we cannot write this is equal to Laplace transform of f of t times Laplace transform of g of t. This is not valid. So we have to convert this function in such a way that we can use the Laplace transform formulas of standard functions. So you can see here we have sine and cosine, and angle is 2t for both the functions. So we can use this formula. We know that sine 2 theta is equal to 2 times sine theta times cos theta. Therefore sine theta into cos theta will be equal to 1/2 into sine of 2 theta. So with theta equal to 2t, we can rewrite our function as sine 2t cos 2t can be written as 1 by 2 times sine of 2 times 2t. We have to double this angle 2t, that is 2 times 2t. Therefore this is 1/2 times sine 4t. So we have converted this function into another function whose Laplace transform we are able to find out. Therefore Laplace transform of sine 2t times cos 2t is equal to Laplace transform of 1 by 2 times sine 4t, and this is equal to 1 by 2 times Laplace transform of sine 4t. And we have ready-made formula for the Laplace transform of sine 4t. It is equal to 4 divided by s square plus 4 square. We are using this standard formula for Laplace transform of sine at. It is given by a divided by s square plus a square, and here a equal to 4, and here this 2 will cancel out with this 4, and we have 2 divided by s square plus 16. So therefore Laplace transform of sine 2t times cos 2t equal to 2 divided by s square plus 16. So we have to understand that we don't have any formula for the Laplace transform of product. So we have to convert our product of two functions in another function whose Laplace transform is known to us. In this case we are able to write sine 2t into cos 2t in terms of sine function, and we are having Laplace transform of sine function. We have ready-made formula and we are using that formula. Another function is sine 2t times cos t. So here also we have product of two functions sine 2t and cos t, but here angle is different. In sine we have angle 2t and here angle is t. So we cannot use that formula sine 2 theta equal to 2 sine theta into cos theta. So for this if we recall that we have this formula 2sc equal to s plus s. This we can write as 2 sine alpha into cos beta. This is equal to sine of alpha plus beta and plus sine of alpha minus beta. 2 times sine alpha cos beta equal to sine of addition of these two alpha plus beta in plus sine of subtraction of alpha and beta. So we can use this formula and we can write our function in terms of another function whose formula is known to us. If we compare with 2 sin alpha cos beta, instead of alpha we have 2t and beta is t, and we are not having 2, so this we can rewrite as 1 by 2 times sin alpha plus beta plus sin alpha minus beta. So whenever angle is different, we can use this formula 2sc equal to s plus s, and using this formula first we rewrite our function sin 2t cos t equal to 1/2 times sine of 2t plus t plus sine of 2t minus t, and this is equal to 1/2 times sine of 3t plus sine t. So we have converted this product into addition of these two functions, and we have ready-made formula for the Laplace transform of sin 80, and using that formula we can find out Laplace transform of sin 2t times cos t equal to 1 by 2 times Laplace transform of sin 3t plus sin t. So let me write one more step, Laplace transform of sin 3t plus sin t, and this is equal to 1/2 times Laplace transform of sin 3t plus Laplace transform of sin t, and this is by linearity property of the Laplace transform, and this is equal to Laplace transform of sin 3t is 3 divided by s square plus 3 square, 3 square is 9, plus here coefficient of t is 1, 1 divided by s square plus 1 square, which is 1. And if we wish, we can simplify this, we can take LCM, and we have these two also. LCM is s square plus 9 times s square plus 1, and this 3 is multiplied with s square plus 1 and plus 1 times s square plus 9, that is s square plus 9, and we can again rewrite 2 times s square plus 9 times s square plus 1. Here we have 3s square plus s square, so that we can directly write as 4s square, and then 3 into 1 3 plus 9, 9 plus 3 is 12, and again we can cancel out this 2, and we first write this 4s square plus 12 as 4 times s square plus 3 divided by 2 times s square plus 9 times s square plus 1, and we can cancel out this 2, and here we will have 2. So this is the Laplace transform of sin 2t times cos t. Here angles are different, therefore we are using this formula 2 sin alpha cos beta equal to sin alpha plus beta plus sin alpha minus beta. Here angles are same, angle is 2t, therefore we are able to use this formula. So be careful, you have to check whether angles are same or different. You may have this type of situations also, so let me recall these formulas. We will require 2sc is equal to s plus s. Similarly 2cs is equal to s minus s. 2cc is equal to c plus c, and this c minus c is equal to minus 2 times s into s. So if we have this type of things, suppose I have sin 4t into sin say 3t, then I will use this last formula, and I will write this in terms of cosine functions using this formula. So whenever you have this type of product of this type of sine and cosine functions, and if angles are different, then you can use appropriate formula and you can write your product in terms of those functions whose Laplace transforms are known to us. Let's take another example. Here we have to find out Laplace transform of 1 divided by square root of t, and this we can rewrite as 1 divided by t raised to 1 half, and this we can rewrite as t raised to minus 1 half. So for this we have to use this formula which we have derived. Laplace transform of t raised to n is given by gamma n plus 1 divided by s raised to n plus 1, and this is valid for all values of n which are strictly greater than minus 1. And you can compare this t raised to minus 1 half with t raised to n, and here n is minus 1 by 2 which is greater than minus 1. Therefore we can use this formula. So here in this formula we just have to put n equal to minus 1 by 2. Laplace transform of 1 divided by square root of t equal to Laplace transform of t raised to minus 1 half, and using this formula for n equal to minus 1 by 2, we have gamma function of minus 1 by 2 plus 1 divided by s raised to minus 1 by 2 plus 1. Minus 1 by 2 plus 1 is gamma 1 by 2, and in the division we have s raised to 1 by 2, and we know that gamma 1 half is square root of pi, and s raised to 1 by 2 can be rewritten as square root of s, and this is again rewritten as square root of pi divided by s. Therefore Laplace transform of 1 divided by square root of t is equal to square root of pi divided by s. So you must remember all those standard Laplace transform formulas, and you can easily evaluate Laplace transform of this type of functions. Another function is sine of omega t plus delta. So suppose I had sine omega t, then I can directly find out Laplace transform of this function using this formula, s square plus omega square. But I am not having this type of function here. I have plus delta. So for this also we have to write this function in terms of those functions whose formulas are known to us, and for that we recall this formula: sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. We will use this formula with alpha equal to omega t and beta equal to delta. So first we rewrite our function using this formula: sine omega t times cos delta plus cos omega t times sine delta. Here delta is constant, therefore cos delta and sine delta are constants. And now we can use linearity property. Therefore Laplace transform of sine omega t plus delta will be equal to Laplace transform of this addition of two functions, where cos delta and sine delta are constants, and therefore by linearity property of Laplace transform I can directly write this as cos delta times Laplace transform of sine omega t plus, here sine delta is constant, sine delta times Laplace transform of cos omega t. So I am using linearity property of Laplace transform. Laplace transform of a into f of t plus b into g of t is equal to a times Laplace transform of f of t plus b times Laplace transform of g of t. So this I have written using this linearity property, where constants a and b are cos delta and sin delta. F of t is sin omega t, g of t is cos omega t. And then we write down the formulas for Laplace transform of sine and cosine. Laplace transform of sin omega t is omega divided by s square plus omega square, and Laplace transform of cos omega t is s divided by s square plus omega square. And this we can rewrite by taking LCM as s square plus omega square, and here omega times cos delta plus s times sin delta. So this is Laplace transform of sin omega t plus delta. So in this way we can find out Laplace transform of cosine of omega t plus delta also. So for that we recall that formula: cosine of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. So here alpha is omega t, beta is delta, and expand this using this formula and use the formulas for Laplace transform of cosine and sine. So whenever you have this type of functions, you first you have to convert them into those functions whose standard Laplace transform formulas are known to us, and then if you are able to convert them into known standard functions or into the functions whose formulas are known to us, then we are able to find out Laplace transform of given function. So this is all about this session. I hope you like it. Thanks for watching.